Okay, let's look at finding the derivative of a square root function here. So guess what? Square root functions almost always involve multiplying by the conjugate. But let's see if we actually have to use that or not in this situation. So we always start with finding the f of x plus delta x first, just separate from the limit definition so that we don't get things all jumbled up. So we are replacing this x right here with x plus delta x. So then that plus 1 is still there under the square root. Now, there's nothing for us to simplify. Just like I mentioned the other day, x and delta x can't combine those. Okay, they both have an x, but they're different types of x here. Okay, so let's look at our limit definition. That says f prime of x, the derivative of f, is equal to the limit as delta x approaches 0 of f of x plus delta x, so that expression we just found up there, minus f of x, so the square root of x plus 1, all over delta x. So I haven't really looked at it from this perspective yet, but think about what would happen if we went ahead and plugged in 0 for delta x. If we plug that in the numerator, we get the square root of x plus 1 minus the square root of x plus 1. That's 0, and then we also get 0 in the denominator. So that's an indeterminate form. Therefore, our way of fixing that with square roots is to multiply by the conjugate. So we multiply by the conjugate of the part with the square root. This is what most people messed up with on that quiz. The conjugate is changing the sign between the two square roots, or between the square root and the other term, whatever it may be. And we multiply it top and bottom. But remember, we're only actually going to multiply it out in whichever piece already had the square root. So in this case, we're multiplying it out in the numerator. We don't multiply it out in the denominator. We just hang tight with it right there in the denominator. So let's see what happens when we simplify, when we multiply this out here. So when we multiply the square root of x plus delta x plus 1 by the square root of x plus delta x plus 1, square root times the square root of the same thing just leaves you with what's under that square root. So x plus delta x plus 1. The outside is plus those two square roots times each other. The inside is minus those two square roots times each other. Okay, that's what's supposed to happen. They're supposed to cancel. And then we've got, for the last, we have a negative times a positive. So that's a negative. We need to put parentheses, because the square root of x plus 1 times the square root of x plus 1 is just x plus 1. But we're going to have to apply that negative for everything that's supposed to cancel to actually cancel. So then we've got delta x times all this stuff on the bottom. We're not multiplying it out. We're just going to leave it there for right now. Okay, so let's see what simplifies here on the top. When we distribute that negative, we've got x minus x. That cancels. We've got 1 minus 1. That cancels. So all we have left on the top here is that delta x. We don't have anything else left on the top because the x canceled, the 1 canceled. So this looked like it was going to be a big, nasty, long process, but very quickly we have gotten to a point where we're almost finished. Remember what happens right here? Those delta x's cancel, but please, please, please don't forget that you need to put a 1 there on top, okay? That denominator doesn't just magically move to the numerator because we canceled out what was in the numerator. Okay, so we've removed our problem. The delta x was part of the problem, the delta x in the denominator. So at this point, we can plug in 0 for delta x. So we've got x plus 0 plus 1 plus the square root of x plus 1. Well, look at what happens. X plus 0 plus 1 is just x plus 1. So we have 2 of those square roots of x plus 1 in the denominator. So this is the derivative of the square root of x plus 1. Okay, that expression right there is the derivative of the square root of x plus 1. I have the derivative notation at the very beginning. Okay, but I went ahead and put it there at the end to emphasize that that's what that is. Okay, that equals the derivative of this particular function. Okay, and remember, no rationalizing needed in calculus. We multiplied by the conjugate earlier to get rid of the issue. We weren't rationalizing. Okay, we can leave that square root in the denominator. We don't have to do anything with that. Okay, so let's look at finding the derivative of a rational function. Okay, finding the derivative of f of x is equal to -3 over x plus 2. So again, let's start with f of x plus delta x. So we are replacing this x right here with x plus delta x. Okay, it's great if there's something that we can simplify. There's nothing to simplify here. No like terms that we can combine, nothing that we can reduce. So then we hop on down to our derivative limit definition of the derivative. Okay, I'm trying to use these terms as often as possible to get them ingrained there in your memory. Okay, this is the limit definition of the derivative. F prime of x, the derivative of f, is equal to the limit. You know what? Let me use the, on second thought, let me use the h. Okay, let me use the h. Just to get you used to, sometimes they like to use the h notation. So let's use the x plus h definition. Okay, it's the exact same thing. All right, they're just using h instead of a delta x. So it's actually, we have a little bit less to write. So we've got 3 over x plus h plus 2, the f of x plus h, minus f of x, okay, just plugging in the original function, all over h. Okay, notice, again, if we plugged in 0 for h right here, we would get 0 on the top, and we would get 0 on the bottom. So that means we've got to take care of that problem. First thing that I want to do is, since this is minus a -3 over x plus 2, subtracting a negative, same as adding a positive, okay? Go ahead and just get that out of the way. Now, remember back when we were doing these limits, we were trying to evaluate it. What did we do? We had to multiply by the LCD. Now, in this case, this x plus h plus 2 and x plus 2 are together the LCD. So x plus h plus 2 and x plus 2, x plus h plus 2, and x plus 2. If you can see what's going to cancel, you can go ahead and do that, all right? But I'm just trying to be thorough and clear in what I'm doing. Okay, I got to multiply all three terms there. The first rational expression, the second rational expression, and the h there in the bottom, I've got to multiply. So the x plus h plus 2 cancels in the first one. So let me start a line here with what we've got left. So we've got -3 times x plus 2. I'll multiply it in the next step, plus the x plus 2 cancels in this one, so we've got 3 times x plus h plus 2, over, don't multiply this out, okay? Do not multiply this out. Leave it in factored form. Think about complex fractions, okay? Our goal was to see if we could cancel anything, so the easiest way to cancel things is to leave them in factored form, okay? But in the numerator, because of this plus right here, we do need to distribute so that we can combine like terms, because we can't cancel anything right now because of that plus. So let's do that. Let's distribute the -3 and +3 there in the numerator. So we've got -3x minus 6 plus 3x plus 3h plus 6 all over h times x plus 2 times x plus h plus 2. So let's see what cancels. -3x, +3x. -6, +6. So let's see what we've got left here. The limit as h approaches 0, because I haven't plugged in 0 yet, so I've got to keep my limit notation. We've got 3h left in the numerator. We've got h times x plus 2 times x plus h plus 2. Now we can cancel the h's. Guess what? The problem is gone. We're no longer going to get 0 over 0 when we plug in 0 for h. So I had 3 left in the numerator. I'm plugging in 0 for h. Okay, so guess what I get in this problem? 3 over x plus 2 squared, because I got 2 of those down here, because x plus 0 plus 2 is just x plus 2. So we've got two of them. So that is our derivative of the rational function -3 over x plus 2. That's what its derivative looks like. Okay, so I've got some textbook problems that I want you to do to practice those skills. Check the page to see what problems you're supposed to do.